All right, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. As you are walking in, you're grabbing a handout. It has warm-up 102 on there. Work on that really quick so you don't have to copy anything. I also included the agenda in there and a little table that we need to fill out. So grab your handout. The warm-up shouldn't take you more than 7 minutes. Let's get started, please. Go. All right, for the sake of time, I'm going to get started. Number one, it says make an input-output table with a domain -3 to 3. So x, f of x, -3, -2, -1, 0, 1, 2, and 3. And our function is f of x equals 1 over x, so parentheses for x, if I substitute -3 there, it's -1/3. -2 there is -1/2. -1 there is -1. That one is undefined. Then 1 there is 1, 1/2, and 1/3. Let's graph that. -1, -2. -3, 1, 2, 3. Got -1 of y down here, and +1 of y up there. We got -3 1/3. It's about right here. Oh, -1/3 down here. -2 1/2. -1, -1. On the other end, we have 1, 1, 2, 1/2, 3, 1/3. There you go. Once again, students, rational function, students. Number 2. Says transform that function. So, our cubic function, once again, it goes through the point of origin. And what happens to that? According to this negative here, it flips. And then from there, it goes 6 to the right and 5 down. 6 to the right and 5 down. So that means it's going to be now somewhere down here. Number 3A. Standard form, yes. GCF, no. So let's group and group. GCF for the first two is 3x. We're left with x plus 3. GCF for the next two is -2. We're left with x plus 3. What's the same there? X plus 3 and 3x minus 2. This one over here, standard form, yes. GCF, no. 3 times 2 is 6. 5, what factors of 6 add up to 5? 2 and 3. However, we have a coefficient of 3. So, can we simplify that fraction? No, that is 3x plus 2. Can we simplify this fraction? Yeah, 1 over 1, which means 1x plus 1. So far, so good. Let's go to number 4. But of course, you guys already finished all this. I'm just behind schedule. Sorry about that. All right. Is it in standard form? Let's see. 3, 1, 0. Yes. Is there anything missing? Yes. The second degree. So this one, 1, 0. Set it equal to 0. Solve. +1 + 1, x equals 1. So that's my divisor. My coefficients are 5. For the second degree is 0, -3, and 15. Bring down the 5. 1 times 5 is 5. Combine, that's 5. 1 times 5 is 5. Combine, that's 2. 1 times 2 is 2. Combine, that's 17, my remainder. So if we started with a cubic, that means this one now is a squared plus 5x plus 2 plus the remainder, which is 17 over x minus 1, which we get from over here. And last but not least, number 5. Solve the quadratic equation. Set it equal to 0. Is it in standard form? Yes. Any GCF? No. Negative 24, negative 2. What factors of negative 24 add up to negative 2? That's negative 6 and 4. So my factors are x minus 6, x plus 4 equal to 0. From there we set each of those equal to 0. So plus 6, x equals 6, minus 4, x equals negative 4. These are my solutions. X-intercepts, zeros, or roots. Ooh-wee. Rockin' and rolling, Enrique. Let's go. All right, the agenda for today, warm-up 102. We're on polynomial equations and zeros. Tonight's home plate, 8 polynomial equations and graphs. So, copy the code, JDGB2, JDGB2. Now, as I mentioned yesterday, my Nearpod is having issues, a little bit of issues, and it's zooming in, zooming out. I don't know what it's doing, but I said in the video, if you are having issues at accessing the home plate, where else do you go? To the YouTube channel. Yeah, go to the video lesson, and it should be in there. Like right now, I'm recording as we speak, so the home plate should come up on the screen once I get to that section. Yeah? All right. So last night's home plate were those 4. Go to Canvas, turn that in, please. Get your Chromebooks out. Tonight's home plate, there it is again, in case, once again, Nearpod does not give you access. Once again, those 8 home plate problems are going to be in the video, just in case Nearpod does not give you access. All right? From there, get a Cornell note ready, and once you turn in your home plate, put away those Chromebooks. You're not going to need them for the sesh. Thank you. All right, here we go. I can graph polynomial equations. So yesterday's home plate was good. Today's going to be gooder. Yes, that's my word. Go tell your language arts for it. Let's go. So, we're graphing. We know by now what polynomial equations are. You took notes already on that. Remind your neighbor the definition. See if they remember without looking at your notes. Polynomial equations are what? Very good. 2 variable equations where we have monomials and multinomials. There it is. All right. We talked about zeros and rational numbers. We talked about the rational zero theorem that you used last night's home play. We did a couple of those examples, which brings us to here. Get this graph in front of you. Now, I do want to elaborate on those really quick. Now, we've been working so far with the following parent functions. Write this down. F of x equals x. And what does that look like? Like this, a straight line. Now, before I continue, look up. When you have a coordinate plane like this, it's broken down like follows. This section right here is known as quadrant 1. This one is quadrant 2. This one is quadrant 3. And this one is quadrant 4. Okay, so look at our parent function f of x, known as a linear function, linear. What quadrant does that graph begin if we go from left to right? Tell your neighbor, what quadrant does it begin? Everyone? 3. That is correct. And what quadrant does it end? Everyone? 1. That is correct. It starts at 3 and it ends at 1 over here. Starts at 3, ends at 1. All right. Next. The next parent function that we worked with is f of x equals x squared. And that graph looks like this. Once again, if we read that graph from left to right, what quadrant does it start at? 2. That is correct. And where does it end? At 1. From there, let's go to the next parent function. F of x equals x cubed. And it looks like this. What quadrant did it start and what quadrant did it end? Starts at 3 and it ends at 1. Now, for the sake of illustrating the following, write f of x equals x to the 4th power. You're like, oh, snap. What is that going to look like, Mr. Q? Like this. Look up. Very thin. And then it's going to flatten out for a little bit and then go back up. And once again, what quadrant does it start? At 2. And what quadrant does it end? At 1. Now, can we conclude that any function ends at quadrant 1? Can we conclude that? Yes? Any function ends at what? Quadrant 1. Okay. However, their start is different from one another. But I want you to see something. Look up. Let's see if you see what I see. Talk to your neighbor, let them know what they see. See if they see what you see. All right, just to double check, look up. Here goes another. See what you see. This one and this one. And by the way, what is the invisible exponent here? A 1. Okay. So, what can we conclude? What can we conclude? What observation can you give us? Let's go over here to Renzo. Give us an observation. What do you observe? What did your neighbor say? Since I asked you guys to tell your neighbor. All right, help him out. Let's go with Elijah. What do you see? The odd exponents begin at quadrant 3 and the even exponents begin at quadrant 2. Hands if you see that. All right. So what if I did this? Look up. Where does it start and where does it end? Tell your neighbor. Where does it start and where does it end? All right, where does it start? Let's go back over here to Geo. It starts where? At 3, and it ends at 1. Whatever happens in between, but that's where it starts, that's where it ends. Is everybody seeing what we're seeing? All right, so if I was to say f of x equals x to the 1,000th power, tell your neighbor where it starts and where it ends. It starts at what? 2, and it ends at 1. Okay, we get it, right? Now, in regards to transformations, look up. Tell your neighbor, what would happen to all these parent functions if I did this? Tell your neighbor what happens to all those functions. What happens to all those functions if I did that? Gio, pass on one. Mario. They turn into negative, and what happens to the graph? It flips. That is correct. Like so, like so, like so, and like so. Everybody agree with that? Yes? All right. Therefore, on your notes, copy this one, please. Example 1. Graph the polynomial function f of x equals x minus 3 times x plus 2. That goes in your notes. You can do that in the back of that play sheet you got. Example 1, graph the polynomial function f of x equals x minus 3 x plus 2. All right, here we go. I'm going to write some steps on the side so you can have them yourself as well. Step 1, they need to be in factored form. What does that mean, Mr. Q? Multiplying. Let's see. Is this multiplying that? Yes. Okay. Step 2, equal to 0. Set it equal to 0. Step 3, set each factor equal to 0. So x minus 3 equal to 0, x plus 2 equal to 0, 4 solve, plus 3 plus 3, x equals 3, minus 2, x equals negative 2. Bless you. And 5, graph. All right, so get a coordinate plane going. It's going to go pretty fast, so stay with me. All right, here we go. Look up, please. Question: how many x's do we have here? How many roots? 2. That means, look up, that the parent function for this one is f of x equals x squared. Yes? Because it's got how many x's at the end? 2. Therefore, tell your neighbor where this graph begins and where this graph starts if the parent function is a quadratic. Where does it start and where does it end? Mario, pass someone. Enrique. Where does it start and where does it end, the graph? Since we have 2 x's, that means the parent function is x squared. Starts at 2, and it ends at 1. Thank you, Enrique. Okay, so we have that, beginning and end, but now we have the roots. These are my zeros. X equals 3, 1, 2, 3, plot it. And x equals negative 2, 1, 2. And all we have to do is connect the arrow to the zeros and to the other arrow from left to right. Here we go. And we're done. Do another one. Example 1Q. G of x equals negative x plus 8 times x minus 1. Q. Here we go. Step 1. Is it in factored form? Yes. Step 2, set it equal to 0. Step 3, set each of those equal to 0. Let's graph. All right, here it goes. How many x's do we have at the end? 2. That means the parent function is x squared. So where do we start? Where do we end? Enrique, pass on one. Who? Yulisa. If it's a second power, where do we start? Where do we end? 2. And end at 1. Now, be careful with this one. Look up, please. Let's plot our x's. We got -8. -8 is somewhere over here. And +1 is about right here. However, look up. Tell your neighbor what's going to happen to these arrows according to that. Tell your neighbor what's going to happen to those arrows. Yulisa, pass on one. Who? Kelly. It's going to flip. So instead of being at 2, 1, we're going to 3 and 4. Going from left to right. There it is. From 1 to 5, what come to are you at so far? 4, 5, 4, 5, okay. Let's do another one. Let's crank it up. Example number 2. Write this down. P of x equals, parentheses, x minus 6, x plus 4, x plus 7. Let's see. Follow the process. I'm going to give you a head start for this one. See if you can do that one by yourself. Go. All right, here goes the process. First step, is it in factored form? Yes. Set it equal to 0. X minus 6, x plus 4, x plus 7. Set them equal to 0. X minus 6 equal to 0. X plus 4 equal to 0. X plus 7 equal to 0. Solve. Plus 6 plus 6. X equals 6 minus 4 minus 4. X equals -4 minus 7 minus 7. X equals -7. These are my what? My roots. Okay. Hands if you got it to right there. All right. Let's graph that. However, let's double check. Before we get started, we need our arrows to see where it starts, where it ends. First of all, how many x's do we have? Everyone. 1, 2, 3. So the parent function is what? X cubed. Yes? Therefore, where does it start? Where does it end? Everyone. At 3. And it ends at 1. All right. And let's graph our roots. X equals 6 is somewhere over here. -4, -7, going from left to right, there you go. This flattened out right there, that was my board. Hold on, make sure you curve it as much as you can. There you go. Process is the same, yes? From 1 to 5, how come are you with that so far? All right, 5, 4, 5, 4. Let's do another one. Copy this one. Example 2Q. We have the polynomial function P of x equals negative x minus 8 times x minus 2 times x plus 5. See if you can do that one by yourself. Go. All right, check with the neighbors, see where they're at. See if they have something similar to you. See if they caught that little curveball I threw at you on there. All right, here we go. Is it in factored form? Yes, Mr. Q. Set it equal to 0, negative x minus 8, x minus 2, x plus 5. Set each factor equal to 0, x minus 8 equal to 0, x minus 2 equal to 0, x plus 5 equal to 0. Solve. Plus 8 plus 8, x equals 8, plus 2 plus 2, x equals 2, minus 5 minus 5, x equals negative 5. These are my what? Roots, or my zeros. So, how many x's do we have? 1, 2, 3. So it comes from the parent function x cubed. That means it starts where, everyone? At 3. And it ends where? At 1. However, let's graph our zeros first. We got 8. We got 2. We got negative 5. Am I forgetting anything? Tell your neighbor what I'm forgetting. The negative. What does that do to the beginning and starting arrows, Joseph? It flips it. So instead of being down here, it's up here. And instead of being up here, it's down here. All right, let's connect those arrows from left to right going through those points. There you go. Hands if you got that by yourself. All right, not bad. Let's go. Let's crank it up a bit. Copy this one. Example 2 super Q. G of x equals x minus 4 times x plus 3 squared. All right, step 1. Is it in factored form, people? No. G of x equals x minus 4, x plus 3, x plus 3. Next step, set it equal to 0. X minus 4, x plus 3, x plus 3. Set each equal to 0. X minus 4 equal to 0, x plus 3 equal to 0, x plus 3 equal to 0. Solve. Plus 4 plus 4, x equals 4, minus 3 minus 3, x equals negative 3, minus 3 minus 3, x equals negative 3. These are my zeros. How many x's are there? 3, so they come from the parent function f of x equals x cubed. Get a coordinate plane on the side. Now let me show you, this one's a little bit different. Writing utensils down, look up to the screen. Check this out. Writing utensils down. Here goes. My first one is x equals 4. Okay, about right there. The next one is x equals negative 3. But, Mr. Q, there's another one. Oh, okay. Now, why did I emphasize in making that bigger? Because of this. Watch. Where does it start? According to this one is a third degree. It starts down here. And it ends where? Up here. Whenever it's a double root like that, you make it thicker. Check this out. Look what it's going to do. It can't go through it. It bounces off of it. You see what I did? Whenever it's a double root, you bounce off of it. You do not go through. Make a little note for yourself. Put a little asterisk, a heart, aww, and then point to that and say bounce off a double root. All right? before I move on, once again, explain it to your neighbor, please. Make sure they understand what we just did right there, please. Before we move on, tell them what we just did on that graph. All right? Shall we? Let's go. Example 2 super duper Q. Write this down. G of x equals negative x minus 3 squared times x plus 7. I'll give you a head start for that one as well. See if you can do that one by yourself. Go. All right, let's see. Help me out with this one. Step 1, what do I do first? Let's go over here with Enrique. Factor form, okay, so then g of x equals negative x minus 3 times x minus 3 times x plus 7. Next step, pass on one. Mario? Equals to 0. Ooh, that was a tough one right there. X minus 3, x minus 3, x plus 7. Next step, pass on one. Mariah. And solve, yeah? 6 plus 3 plus 3, x equals 3, plus 3 plus 3, x equals 3, minus 7 minus 7, x equals negative 7. All right. Now, how many zeros do we have? 3, so it comes from where? F of x equals x cubed. Let's graph that. So my zeros are 3. Got it? And then another 3. And then negative 7. Where does it start? Where does it end? It starts over here, and it ends over here. However, are we missing anything? Pass on one, Mariah. Kelly, are we missing anything? The flipped. That is correct. So that means instead of starting over here, we start over here, and we end over here. All right, here we go. We go through this one. And instead of going through this one, we just what? Bounce off of it. Hands if you got that. All right, from 1 to 5, how come through are you with this so far? All right, let's crank it up a bit. Copy this one, example 3. F of x equals x minus 7, x minus 3, x times x plus 2 times x plus 6. You should be able to do this one completely. I'll give you guys a head start. Copy and go. All right, let's see. For the sake of time, is it in factored form? Yes. Set it equal to 0. X minus 7, x minus 3, x plus 2, x plus 6. Then set each one equal to 0. Solve. Plus 7 plus 7, x equals 7, plus 3 plus 3, x equals 3, minus 2 minus 2, x equals negative 2, minus 6 minus 6, x equals negative 6. These are my zeros. How many of them? 1, 2, 3, 4. So it comes from the parent function, x to the 4th. So tell your neighbor, where does it start and where does it end? Where does it start? Where does it end? Gio, where does it start? Where does it end? Starts at 2 and it ends at 1. That is correct. Does it have any flipping? No. So then we go to negative 6, which is over here. -2, +3, and 7. From left to right, connect the arrows. There you go. From 1 to 5, how come to argue with this? Yeah, 5, 5, 5, okay. Pretty straightforward, yes? All right, last one. Y'all ready? Example 3, super duper Q. Let me zoom into that one. It starts with Q of X equals to all that. Q of X equals negative times X minus 9 times X minus 5 squared times X minus 2 times X minus 4 squared times X plus 8 squared. You all right over there, Mario? Okay. Once again, you should be able to do this one by yourself, the whole thing. Okay, I'm going to zoom out. All right, for the sake of time, here we go. Is it in standard form? In factored form, almost. So it would be Q of X equals negative X minus 9 times X minus 5 times X minus 5 times X minus 2 times X plus 4 times X plus 4 times X plus 8 times X plus 8. All right, 0 equals negative X minus 9 times X minus 5 times X minus 5 times X minus 2 times X plus 4 times X plus 4 times X plus 8 times X plus 8. Set each one equal to 0. X minus 9 equal to 0. X minus 5 equal to 0. X minus 5 equal to 0. X minus 2 equal to 0. X plus 4 equal to 0, X plus 4 equal to 0, X plus 8 equal to 0, and X plus 8 equal to 0. So, I'm just going to write solutions for all of those. This is X equals 9, X equals 5, X equals 5, X equals 2, bless you, X equals negative 4, X equals negative 4, X equals negative 8, and X equals negative 8. Are we there so far? Yes? How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8. So that means it comes from the parent function what? X to the 8th. So where does it start? Where does it end, Joseph? 2 and 1. All right. However, what do we need to do first? Flip it. That is correct. So we start now at 3 and end at 4. All right. Start with X equals 9. X equals 9 is over here. X equals 5 2 times. 1, 2. X equals 2 is 1. X equals negative 4 is twice. 1, 2. I'm making the double the size, and negative 8 double. All right, here we go from left to right. Does it go through -8? No, it bounces off. Does it go through -4? No, it bounces off. Does it go through 2? Yes. Does it go through 5? Bounces off. And then goes through 9. There you go. Woo-wee. Let's go. From 1 to 5, how come are you with this? Yeah, 5 fours, 5 fours. Okay. Once again, on the YouTube channel, there's the home plate once again. It's only 8 problems for tonight. Only. Enjoy your home play. I'm going to go ahead and stop the video right there. Those of you following along, make sure you practice. See you guys next time. Peace.